For the final topic of this course, we're going to finish up two-port networks. And in the last video, we looked at the admittance and impedance parameters. Now we're going to look at the hybrid and transmission. So unfortunately, for the hybrid and transmission parameters, it's not so easy to set up the equations that we're really trying to find. But we have the 2x2 given matrices right there. For the hybrid, you can see that on one side you have V1 and I2. And on the other side, you have I1 and V2, but the values are flipped. And for the transmission on one side, you have V1 and I1, and on the other side, you have V2 and I2. So the transmission are a little bit easier to look at than the hybrid parameters. But nevertheless, we can derive what all of the values for H and T are. And notice for some of the values, you have I2 being equal to 0, V2 being equal to 0, I1 being equal to 0, and I1 again being equal to 0. So a little bit weird. And then for the transmission, you have I2, both being equal to 0, V2, and then V2, both being equal to 0. But notice this negative sign you get right here. So just laying the basis for these other two parameters and noticing the non-uniformity of the units for H and T. Now there's a few questions that might come up. Two of the questions that came up for me originally were, how do I know when to use which parameters? And what's the point of having 4 ways to model this? Really just seems like overkill. But for that, we need to consider that these two-port networks can also be represented in different forms. So we can have a parallel two-port network, given here on the left, where we have one network A, one network B. We still have V1 and V2, but inside each of these networks, we break them up into A and B, respectively. So if we can form a circuit into a parallel two-port network, we can simply say that the total admittance parameters of the entire system will be equal to the admittance parameters of A plus the admittance parameters of B. Now, if we have a series two-port system, it looks like the following. We can simply say that the total impedance parameters will be equal to the impedance parameters of network A plus the impedance parameters of network B. And lastly, if we have a cascading two-port network that looks like this, we can simply say that the total transmission parameters are equal to the transmission parameters of network A plus the transmission parameters of network B. Unfortunately, I couldn't find much with hybrid parameters for when you know you should use them, but this should answer one of the questions of how do I know which parameters to use? And for the second question of what's the point of having 4 ways to model this, even the hybrid parameters, they kind of just seem like the redheaded stepchild. But that being said, we can look at a table where we can actually have the conversion between admittance, impedance, hybrid, and transmission parameters. And that's given here in this 4x4 table. So what we can say from this is that if we have the parameters given in Y, we can simply find what they are in either Z, H, or T, simply by using the equations in each one of these cells. And just note, this delta term is simply given by this equation here. Now coming back to that second question of why do we even need 4 parameters? Well, maybe you have a circuit that's really easy to model in the hybrid parameters. Maybe it gets really messy if you look in Z, T, or Y. So you can get everything in the hybrid parameters, and then from the hybrid parameters, you can actually convert into Z, T, or Y, because you know what H1, H12, H21, and H2 are. So that kind of lays out the answer for question 2. What's the point of having 4 ways to model this? Well, hopefully one of the ways is pretty easy, and then you convert using the table to find the parameters you actually need. And this will do it for the Advanced Circuit Analysis course. I think the next course that I'm going to cover is electronics. I was going to go into coding, but I'm not sure the copyright. But nevertheless, next course will probably be electronics. Thank you for watching. If you learned something, subscribe, like, comment, share. Helps out.